Hi again. Welcome to the fourth and last video on solving simultaneous equations in algebra. In this video we extend our algebraic techniques for obtaining solutions from the context of only linear equations to that of nonlinear equations which might include parabolas, etc. We also extend our scope to include sets of three equations with three variables. Nonlinear equations to be solved simultaneously describe shapes including circles, parabolas, cubics, ellipses and hyperbolas, and very often one of those shapes is to be solved simultaneously with a linear equation. But just as we discussed in earlier videos, the question being addressed is essentially where do a line and a curve or two curves intersect? The nonlinear curves all have powers of x, i.e. in the independent variable, which are other than 1. For example, the parabola has the form y equals ax squared plus bx plus c, so the degree of that equation is 2. The hyperbola may have the form xy equals k or y equals k over x, in which case the power of x is going to be a minus 1, depending on where you write it. The basic technique for solving these equations simultaneously is essentially the same as that we began with, that is, substitution. For example, find the points of intersection between the line 2x minus y plus 4 equals 0 and the parabola y equals x squared plus 1. Now we note that there is a y term in both equations, so just as we did before, replace one y term with the other. From the linear equation we can write y equals 2x plus 4, substitute that into the equation for the parabola. So 2x plus 4 is equal to x squared plus 1. Tidy up, x squared minus 2x minus 3 equals 0, which we can factorise into x minus 3x plus 1 equals 0, which gives us our two x values for the point of intersection of x equals 3 and x equals minus 1. Substitute when x equals 3, y turns out to be 10. When x is equal to minus 1, y equals 2. So the points of intersection between the line and the parabola are 3 and 10 and minus 1 and 2. We could solve simultaneously the equations for a line and a hyperbola. It's exactly the same approach, substitution. Find the points of intersection between 4x minus y plus 3 equals 0 and xy equals 1. Well, change the hyperbola equation so we isolate y, so y is equal to 1 over x. Substitute that into the linear equation, so it becomes 4x minus 1 over x plus 3 equals 0. Clear the x from the denominator, 4x squared minus 1 plus 3x, we write round the other way, equals 0. Factorise 4x minus 1 times x plus 1 equals 0. X equals a quarter or x equals minus 1. Substitute when x is equal to a quarter, y equals 4. That's an easy one. When x is equal to minus 1, y equals minus 1. That's even easier. So the points of intersection are a quarter and 4 and minus 1, minus 1. The final type of equations of the nonlinear variety requiring simultaneous solutions are encountered in some finance questions and with geometric series. Unfortunately, they're very, very rarely taught and often taught in a very complex way. Now, the format is distinguished by having terms multiplied together rather than having at least one equation with terms added together. For example, we may have to solve the following equations simultaneously for a and r. First equation, ar to the 6th equals 3072. ar cubed is equal to 48. Don't try to do a substitution here, just ratio them and divide one equation into the other. ar to the 6th over ar cubed is equal to 3072 over 48. The a's cancel straight away. Take the difference between your indices for r, so r cubed is equal to 64. Straight away, r is equal to 4. Substitute back into one of them, a is equal to 3/4. So simple and so often ignored. So now we change to a different situation where we have the three variable case with three equations, and usually that's a linear set of equations. For example, we might have to solve the equations simultaneously for x, y and z, being x plus y equals 3, 2x minus 3y equals minus 4, and y plus 2z equals 12. Three equations, three unknowns, all linear equations. So such questions like this emphasise algebraic skills. We do very little in three-dimensional space, and so they're going to have limited use in senior high school maths courses. They're just going to be put into assessments and exams to see what your algebra is like. That being said, such questions simply require the application of the first two skills described in the first algebraic video that we looked at, substitution and equating coefficients. So they're going to be pretty simple. So we'll look at that set of three equations, and as before we want to remove at least one variable by substitution. Well, from equation 1 we can write y equals 3 minus x, and then substitute that into equation 2 gives us 2x minus 3 outside of 3 minus x equals minus 4. Tidy it up, we get to 5x equals 5, x equals 1. Substitute into the modified first equation gives us y equals 3 minus 1, which is 2. We can then substitute that y equals 2 into the third of the original equations, and we get z equals 5. So our simultaneous equations have resulted in the point of intersection between them all as x equals 1, y equals 2 and z equals 5. That's in three-dimensional space. Do not forget to check your answers before you leave it by substituting them in to check. In this video we have addressed three advanced aspects of solving equations simultaneously. The implications can be summarised as: first, solving a combination of linear and non-linear equations utilises exactly the same techniques as we use for the basic set of two linear equations, that is, substitution and equating coefficients. Second, two or more equations formed by multiplying terms can be solved simultaneously by using division of the equations. Third, sets of three or more linear equations can be solved through repeated application of the two basic techniques. You now have all the techniques you need to solve simultaneous equations algebraically, be they linear or non-linear. Hope you now understand these techniques and feel confident about using them. Thanks for watching this video. There is a range of other videos on algebra. Check the YouTube playlist for me or the main menu on the website. Hit the like button and subscribe if you haven't already. Also go and do some questions on the non-linear simultaneous equations, Test Yourself 1, on my website drjaysmaths.com. Add a comment below or send me an email if you have any questions. Good luck. See you later in another algebra context.